So mass is 0.04 kg. Bullet is moving with 90 meter per second. Enters a heavy wooden block. This is our bullet. Enters a heavy block and is stopped after a distance of 60 meter. It stops after a distance of 60 meter. What is the average resistive force exerted by the block on the bullet? So let's say the resistive force is in this direction, and here the velocity of this ball is 90 meter per second. So we need to find out the average resistive force. The force is given by MA, right? So if we can find out the acceleration,
Yes, sir.
we can find out the resistive force. Here the distance is given, that is 60 meter. Initial velocity u is given, that is 90 meter per second. So what we can do here, how to find out this acceleration?
The equations of motion, sir, kinematics, sir.
Very good. From v square minus u square is equal to 2as. The final velocity is 0. This will be 90 multiplied by 90, that is equal to 2 multiplied by acceleration multiplied by 60 meters. 0 cancels out. 3 3s are 9, 3 2s are 6. So here acceleration would be 90 multiplied by 3 divided by 2, right? And mass was 0.04 kg. So here resistive force will become 0.04 multiplied by 90 multiplied by 3 divided by 2. So it will be 0.2 multiplied by 9 multiplied by 3, which is how much?
So 1.8 into 3, 5.4.
That gives us how much?
5.4.
5.4.
Sir, 18 3 by 54.
Newton. That is our answer, right? So this was the discussion on
Right, sir.
second law of motion. Now let's discuss example 4.3. The motion of particle of mass m is described by ut plus half gt square. Find the force acting on the particle. So here clearly you can see here acceleration due to gravity. This g is our acceleration due to gravity. So clearly it is our gravitational force, right? It is our weight force. This is the answer. Yes or no? Now we did discuss impulse. Remember? Impulse is given by
Sir, F delta, F dv.
impulse is nothing but change in momentum. You know that F is
So,
equal
sir,
to dp by dt.
dp by dt.
So you can multiply this dt with force, so it will become F dt is equal to dp. This F dt is nothing but our impulse. Impulse is F into delta t is equal to delta p, that is change in momentum. Good?
Yes.
So based on this topic, let's discuss this question 4.4. A batsman hits ball straight in the direction of the bowler without changing its initial speed of 12 meter per second. If the mass of the ball is 0.15 kilogram, determine the impulse imparted on the ball. So impulse is given by F dt or delta p, right? So if we can find out change in momentum, we can find out impulse. That will be mv minus mv. Now they are clearly saying that the batsman is hitting the ball in the same direction, right? Yes or no? So here the
Yes,
speed
sir.
would be minus u, right? That
Right,
will
sir.
be minus 2mu. So the value
Right,
of
sir.
this impulse would be what? Mass is 0.15 multiplied by 2 minus 6. That is our answer.
Got it, sir.
Newton second, right? That's the
Mhm.
unit of
So the
impulse.
unit news. Got it.
Now Newton's third law of motion. What's the Newton's third law of motion?
Sir, every action has an equal and opposite reaction.
Very good. So if you apply a force on a certain body, that means that same body will apply force on you, right? For example,
Hmm.
if you try to hit a wall with your fist, so basically you are applying some force on the wall. So wall actually applies some amount of force on your fist. So that's why we get hurt when we hit a wall, right? So that's the reason behind this phenomena. So
Right, sir.
F1 is equal to minus F2, or you can say F1 plus F2 is equal to 0. Alright, so force always occurs in pairs. Force on a body A by the body B is equal and opposite to the force on the body B by A. Okay, we already discussed this thing, right?
Right, sir.
Two identical billiard balls strike a rigid ball with the same speed but at a different angle. Two identical billiard balls strikes a rigid ball with the same speed but at different angles. So let's say this one hits this wall at an angle theta, right? And get reflected without any change in speed. So initial speed is final speed. As shown in figure, what is the direction of the force on the wall due to each ball? The ratio of the magnitudes of impulse is imparted to the balls by the wall. That will be what? So here angle is given, that is 30 degree. We know that impulse is what? Change in momentum, right? That means final momentum minus initial momentum. So in order to solve this question, we need to find the component of these velocities. So here it will be u sine theta and u cos theta would be in this direction. So here the initial momentum is given by mu cos theta in I cap direction minus mu sin theta in j cap direction. Now if you talk about final momentum, then here it will be u sin theta and its x component would be in this direction, u cos theta. So the final momentum would be minus mu sin theta j cap direction
Sir,
minus mu cos theta in I cap direction. Yes.
सर उनका हमें कैसे पता है कि मतलब उनके y कंपोनेंट्स एंड x कंपोनेंट्स एक दूसरे के इक्वल होंगे जैसे y फाइनल का y कंपोनेंट और इनिशियल का y कंपोनेंट
They told
will
us
be
that
equal to.
initial and final velocity is equal and the angle are also equal since they are getting reflected. That's why.
Alright, sir.
Okay.
Right.
So if we can find out the change in momentum, then we can find out the impulse.
Impulse.
Yes. So here impulse would be the subtraction of both these equations, right? 1 and 2. Basically 2 minus 1. So that will be how much? Minus mu sin theta j cap minus mu cos theta k cap, sorry, I cap minus mu cos theta I cap plus mu sin theta j cap. So these sin theta terms are getting cancelled out.
So could you once again explain कि mu का जब हम एक्सप्रेशन निकाल कैसे डिराइव किया हमने mu is equal to mu cos I cap वाला.
Sorry.
सर हमने वो mu is equal to mu cos theta I cap वाला कैसे डिराइव किया minus mu sin theta j cap.
First we resolve this velocity vector in its component. Okay.
हाँ सर.
Then we wrote down the momentum. We can clearly find out the velocity in terms of its component, right, in x and y direction. Then we simply multiplied it with its mass, so it will become its momentum.
So u cos theta I cap minus u sin theta j cap कैसे है minus कैसे है?
See, here u cos theta is in this direction, right? Rightward direction is positive. Okay, upward direction is positive. But the downward direction is negative. So here u sin theta is in downward direction. That's why it is negative.
Got it.
It is the sign convention, okay?
Right.
Good. So the final thing is this, that the change in momentum is minus mu cos theta I cap. That is our impulse imparted by balls on the walls. Yes or no?
Got it, sir.
Okay, so that is what they asked, right? The direction of the force on the wall due to each ball. It is in minus I cap direction, as you can see. Right? That means in this direction.
Got it, sir. Sir, impulse भी vector quantity है मतलब.
Yes. Good, so this is our answer. Now if we plug these values, we'll end up with our answer. Minus 2 multiplied by what was the mass? Mass is not given. They just, in this example, as you can see, they assume the mass is. So this is our final answer. Good.
Got it, sir.
Now conservation of momentum. What is conservation of momentum? Or we can say law of conservation of momentum. It says that total momentum of an isolated system is constant. For example, let's say this is the box and there are various particles, right? and they are constantly getting hit by each other. Yes or no? So no matter how much momentum changes they individually, the total momentum of this system would be constant. That's the statement. That's the concept. Okay.
Right, sir.
That is how gas particles interact with each other. Okay. We'll discuss these things more in thermodynamics. Okay. About gas
Right, sir.
particle and everything. So here what you need to understand is that initial momentum of the system is equal to final momentum of the system. Okay.
Sir.
This is what this law is all about. That means mu is equal to mvf. This is the important formula. All right. For example, let's say we are firing a bullet, okay, from this gun. Let's say the mass of this gun was capital M and mass of this bullet is, let's say, m1. After firing, we know that it will impart some recoil on this gun, right?
Yes,
The
sir.
bullet will travel with some velocity v, let's say in this direction. So if we apply this conservation of momentum, so initially the momentum was zero because there was no speed or velocity. But let's say after firing, this gun recoils backward with velocity, let's say u, okay. So here final momentum will be what? M multiplied by minus u. Why minus? Because this gun is, the recoil of this gun is in left direction, plus the
Yes, sir.
momentum of this bullet, that would be m1v. Now if we simplify this, we can find out the recoil velocity, that is u, right? That
सर
will be
इसमें M और N अच्छा
m1v divided by, sorry, m1u divided by, यहाँ पे लिखते हो चलो, it will be, u will be what? m1v divided by capital M, where the capital M is the mass of the gun and the m1 is the velocity of this bullet. Alright, so this is the best example of Newton's third law.
सर थर्ड लॉ ऑफ मोशन मैथमेटिकली कैसे रिप्रेजेंट करेंगे?
मैथमेटिकली यही है, यही स्टेटमेंट है. देखो F1 इज इक्वल टू माइनस F2. दिस इज द
और सर ये जो
मैथमेटिकल
कंजर्वेशन ऑफ मोमेंटम जो है,
यस
वो भी थर्ड लॉ ऑफ मोशन का ही है.
यस, ये उसकी एप्लीकेशन तुम कह सकते हो. ओके,
राइट सर.
बिकॉज इट डील्स विद द मोमेंटम, राइट.
सर अगर जो आपने एग्जांपल दिया उसमें बुलेट पे जो फोर्स लग रहा है, उतना ही फोर्स वो गन पे लगा है, तो गन ज्यादा तेज एक्सेलरेट क्यों नहीं करती?
बिकॉज गन की मोमेंट ऑफ इनर्शिया ज़्यादा है, उसका मास ज़्यादा है. ओके, मोमेंटम क्या है? मास इनटू वेलोसिटी, राइट.
यस सर.
इट्स वाई. तो अगर वेलोसिटी
मास
कम
इनटू
है, अगर वेलोसिटी कम है तो उसका मास ज़्यादा है, दैट मीन्स कहीं पे तो वो कंपनसेट करेगा, राइट.
यस सर.
So that's the reason. Okay.